Hello, today we're going to consider a very classical problem that shows up in many physics homeworks or exams. Let's read the question together. Figure shows a system of two blocks connected by a rope. If the system is at rest and is let go, find the followings: the acceleration of the blocks, the tension force in the rope, the distance traveled by the blocks in 2 seconds. Okay, let's start solving this problem by redrawing the given figure. So what do we have here? So two blocks of mass m1 and m2. And these blocks obviously going to move in this direction with a certain acceleration. Let it be a for now. And there is a tension force in this rope, right? So the force experienced by the block 1 is its weight, and the force exerted by the table, which is a normal force, friction force, which is going to oppose the direction of motion, and tension force, which is going to pull it. For the second one is a tension force that's going to try to pull the block up, and then weight of the block, which is going to try to pull down. Let's put all these things in a free body diagram and see how we can balance the forces. So in the case of mass 1, you have normal force, you have the weight, you have a friction force, you have a tension force that's pulling it forward. So normal force is just equal to the weight because block is not moving up or down, so these forces have to be balanced. And if you recall, the friction force is equal to coefficient of friction times the normal force. So friction force becomes just mu times m1g. Now, in the case of in-plane forces, well, so the net force is going to be, since block is going to be moving forward, going to be tension minus the friction force, right? And according to the Newton's second law, it has to be equal to the mass of the block times the acceleration. So T minus mu m1g has to be equal to m1 times a, or if we move this to the other side of the equation, we end up with T equals mu m1g plus m1a. Now we're going to do the same thing for the second block. In this case, tension force pulls up, weight pulls down, and that's where your mass is. And the net force, since blocks is moving down, is going to be m2g, the weight of the block, minus the tension force, which is opposing it, equals to mass of the block times the acceleration, according to the Newton's second law. And again, here we can find the tension force in a similar manner, and that's what we have. Now the question is asking find the acceleration of the block. How can I do this? Well, I have one equation, so I don't know tension force and I don't know the acceleration. Everything else I pretty much know. Coefficient of friction is given, mass of the block 1 and 2 are given, g we will take to be 10 meters per second square, and so on. So let's set these two tensions equal to each other and try to solve this equation. So you have this equal to this, right? And then we move terms with the acceleration to one side and the other terms to the other side, and we end up with the following equation, and this gives us a to be equal to m2 minus mu times m1 divided by m1 plus m2 times g. And since we know everything here, we just plug in the values and get the value of acceleration to be 4 meters per second squared. So this is the answer for part A. Now let's consider part B. Well, you can already see, since you already know the acceleration, you can calculate the tension force from either one of those equations. And that's what we're going to do. Let's use the first one, and we have acceleration to be mu times m1g plus m1a. We plug in the values for the coefficient of friction, masses, and g, and the acceleration. We get 60 newtons. What happens if we use the second equation? Well, we should get the same value. And indeed, if we plug the values, we still get the 60 newtons. So the tension in the rope is 60 newtons, which is the answer for part B. Now they're also asking, find the distance traveled by the blocks in 2 seconds. Okay, so these blocks gonna travel as one, right? Because they're attached by the rope. Well, how do you find the distance traveled by the blocks. See, in the question they say two blocks connected by a rope. If the system is at rest and is let go, find the following, right? So its initial velocity is 0 because system initially is at rest. And we know the acceleration, we found it to be 4 meters per second square. So we know initial velocity is 0, and we know the acceleration is 4 meters per second square. That we can find it just simply using the formula for the distance from kinematics. Distance is equals to initial velocity v0 times t plus 1/2 at squared. So initial velocity is 0, acceleration is 4, and the time is 2 seconds, and the distance traveled by the blocks within that 2 seconds should be 8 meters per second. And that's the answer for part C. And that's the question.